Good day, everyone. Welcome to the 24 Hours of Pass for SQL Server 2014. We're excited that you could able to join us today. Our session for today, we've got George Lee speaking on SQL Server 2014 In-Memory OLTP end-to-end preparing for migration. As the 24 Hours of Pass name is included, we will have 24 consecutive live webcasts. I believe this is number 4 or 5 in the series. My name is Ryan Adams. I'll be your moderator for today. I'm a past volunteer. I help run one of the user groups in the Dallas, Texas area. I'm a regional mentor for the South Central area of the United States, and I am also president of the Performance Virtual Chapter. We will run through a few slides here and just kind of give you some overviews of some things and how we're going to work today before I hand it over to our speaker. If you'll advance to the next slide for me there. So if you need some help during the session, your GoToWebinar will normally be in the panel will be in there by default in the top right hand side of your screen. It will usually, if you leave it alone for long enough, it will actually shrink over to the side. If it doesn't, you can click the little arrow in order to do that. If it does and you need to see the panel, you can click the arrow again and it will expand back out for you. Underneath that arrow at the very bottom, you'll see that there is a hand there. If you need technical assistance, you may raise your hand and we will get to you and help you the best that we can. Also, inside of the actual screen for the presentation, you'll notice up at the top left-hand side, there is a zoom option. If you'd like to go to full screen, you want to zoom in, make sure you know that is available for you to do. Also, in the panel at the bottom, you'll notice that there is a question area. So if you have questions for the presenter as we're talking through this stuff, feel free to put your questions in there. We'll get to all the questions. We'll have a Q&A section at the end that we'll get to. So feel free to put your questions in there and take advantage of that. At the end, there will be a very short evaluation. We ask that you just take, we're just asking for a couple of clicks. We ask that you would take the time to go ahead and do that for us so we can continue to provide some great free technical training for us. If you advance the slide for me, please. We want to make sure that we thank Microsoft. Microsoft is the sponsor for this event and the event partner. Microsoft is also a global partner of PASS, so we really want to thank them for all their support. We would not be able to provide this training today for everyone for free if it was not for their support. If you could advance the slide for me, please. So all of the speakers actually got announced today for the PASS Summits. The PASS Summit is PASS's big conference that we have every year. It'll be in Seattle this year. We had about 5,000 people last year, expecting that again this year. There's going to be just the best. This is the mecca for SQL Server. So if you work with SQL Server, you're looking for some training, this is the conference to go to right here. There is a price bump. You'll notice the price down there on the right-hand side is $15.95. That's good and through Friday, June 27th. Starting on the 28th, it jumps up by $300. So it'll go to $18.95. You'll also notice that in the blue there that if you contact your local chapter, they'll have a code that you can use that'll save $150 off. If you don't have a local chapter, if you go to SQLpass.org, you can look up and find a local chapter in your area. If for some reason you don't have one in your local area, we do have virtual chapters. And obviously, if you're enjoying the 24 Hours of Pass today, I encourage you to check out the virtual chapters as well. You can go to SQLpass.org and look all of those up. And if you look at the virtual chapters, they will also have codes for you. I mentioned earlier that I'm the president of the Performance Virtual Chapter. If you go to performance.sqlpass.org, that's our chapter. We have a code sitting out there that you can use to save that $150 off. So make sure you guys take advantage of that. If you do it now before the price jump, you can get a very, very good deal. Next slide, please, if you would. So our speaker today is George Lee. He has been a program manager on the SQL Server product team for the past 2 years. His primary focus is in-memory OLTP. He's also focused on OLTP in Azure VMs, backing up to Azure, which was something new that we had in 2014, and SQL Server Security. So with that, George, I will hand it off to you.
All right, thank you, Ryan. Good day, everyone. It's a beautiful morning here in Redmond, and this is George speaking, and I will be talking today about preparing your application to migrate to in-memory OLTP. So by now, I'm assuming that everybody has heard about the new feature coming to SQL Server 2014, which is, in-memory OLTP, which we refer to in the product team as codename hackathon. So we announced this we announced this a year or so ago, and now it's already made its way to the shelves. So let's recap a little bit on the 4 architectural pillars of in-memory OLTP. We decided that we want all the data inside main memory. That this allows us to actually use in-memory data structures that are optimized for in-memory data, and algorithms that are optimized for in-memory data. So this achieves high throughput. We also wanted to compile T-SQL to native code to C code. This allows us to use CPU much more efficiently. We want high concurrency rates. So we want multiple threads to execute in the database all at once without affecting each other to increase throughput and to eliminate lock and latch contention. And the fourth pillar is we decided that we want to integrate this technology with existing SQL Server, so you get in-memory OLTP without buying any other product. So if you have SQL Server 2014, you will have in-memory OLTP. So this is a brief recap of what in-memory OLTP codename hackathon, what this is all about. Now, we've had a lot of questions with our internal users, with some of the external customers that we talked to at conferences like PASS, that people are generally they like this technology, but what goes through people's mind is really, how do I use it? How do I leverage in-memory OLTP for our existing applications? How do I migrate our existing work to take advantage of this in-memory technology and to use it to improve to the maximum amount the performance of their application. So there has been a lot of thought about that inside the product team, and what we came up with is a 6-step process. So first, first you want to analyze the application to see whether or not it is actually suitable. It is actually a suitable scenario for in-memory OLTP. We have some examples coming up on that. Now, if the application is actually suitable, as in the in-memory OLTP can actually provide certain performance benefits, we then want to define the goals, the performance improvements that we want to achieve, and the measures in which we want to evaluate our work based on the goals that we define. So this is basically a target. So for example, I want my application to be 20, 30, 50% faster, or I want my latency to be within 10 milliseconds. Some examples of that. Then we want to identify the bottlenecks within the application. So we have actually developed tooling included in SQL 2014 that helps with the identification of these bottlenecks, what we call the analysis, migrate, and report with the AMR tool. The analysis part actually helps with the identifying of the bottlenecks, and we'll show that later in this presentation. And then once we've identified the tables and the store procedures we want to migrate, um, we want to understand the considerations, some of the considerations that we must take into account when we actually do the migration work. So, for example, memory constraints. For example, storage considerations. For example, hardware. For example, the design of the design of schemas and indexes and so on and so forth. And we will have I'll have extensive information about this part in the presentation later. And then we want to stage the migration to a test server, do functional testing, do performance testing before we move all of that change to our production. So this part, we also have some tooling in the AMR tool, the migrate part, specifically to help with this process. And then at the last stage, we want to measure our performance enhancements against the goals that we set out in step 2, and if necessary, go through the process again with to resolve new bottlenecks to improve the performance even further. So now, speaking of the application, there are thousands and thousands of applications out there. But what we found helpful is we summarize these applications into certain scenarios, and we found it helpful to actually categorize these scenarios as likely to be helpful and unlikely to be helpful. So here are some scenarios that are likely to get performance benefits from in-memory OLTP. First is of course, your classical performance critical OLTP. For example, order processing. If you have an online order processing system, or if you have, say, stock or foreign exchange trading, these are applications that require stringent performance metrics, and these are some of the applications that can benefit from in-memory OLTP. Now, the second category of applications is applications with high data input rate. So, for example, you have millions of rows coming into the system all at the same time, and that we nickname the scenario as shock absorber, as in we absorb spikes in the incoming data rate, and in-memory OLTP can help with that because we can handle a lot more volume with the same hardware. The third scenario that we see people use in-memory OLTP for is they use it as a step in their ETL processing. ETL, of course, means extract, transform, and load. They use in-memory OLTP as a staging table for the transformation process, for the extraction process, and they may use natively compiled store procedure for certain transformations. And the last thing, one of the other scenarios that we see people use, and in fact some of our customers already put that in production, is relational cache. So they leverage the non-durable table that in-memory OLTP offers and use these tables as a high-performance cache that doesn't really care about durability. So, for example, session state for a website, tracking the user's state through each web page. That's a scenario. That's one example of these relational cache scenario. So, if your application is 1 to 4, it is highly likely that your application can benefit from in-memory OLTP, but that doesn't exclude other possibilities. And of course, there are applications that aren't good fits for in-memory OLTP. Now, for the first example being that you don't have permission to actually make code changes. For example, if you have an ISV app, or some vendor app that uses the database, and you can't change the code, that is obviously not optimal for use for in-memory OLTP. Now, if you have a full data warehousing app or reporting workloads that runs long ad hoc reporting queries, you might not want to use in-memory OLTP because it's just not built for that purpose. You might want to instead try the column store indexes we have also in SQL 2014. That is a much better fit for these kind of workloads. Now, if your application also uses a lot of XML manipulation, if you use a lot of full text indexes, this is not a good fit for in-memory OLTP because we, at the moment, do not have good support for these scenarios. And lastly, but not least, if you have queries that are heavily parallelized, this may not be a good fit for in-memory OLTP. It may not be a good fit for native compilation specifically, because currently native compilation for each native compile store procedure for each call, only one thread will execute that call. So with a heavily parallelized query, native compilation may not be the way to go. Now, if you have classified your application and you think that in-memory OLTP can provide you with a good performance benefit, we would suggest that you establish a performance baseline for the application. So we suggest that you establish a baseline with production data. It's more accurate than anything that you can get your hands on, and is much more realistic. But we understand that sometimes it's hard to get access to the production environment. So the other way that we've seen, our internal and external customers do this is we seen them do a simulated workload, and it works for some of them, and results varied. So the main caveats that we see when you use a simulated workload is that you want the simulated workload to be as close to your production workload as possible in terms of, for example, scale, in terms of the transaction mixes, in terms of read and write ratios, in terms of the profiling period. For example, you may choose to run the simulated workload for 2 or 3 hours, or for even longer than that, depending on your workload characteristics. What we don't recommend, and this is what we see a lot in our communications, is we don't recommend you run a test on your workstation with, say, a single spindle disk and say 4 cores, and try to see performance differences between disk-based and in-memory table, because that's not going to resemble what your production environment is going to see. As for the tooling for establishing the performance baseline, we provide quite a few tools. We have the O-Stress tool. This is a tool coming out of our customer support team. We have the distributed replay tool. This is included in SQL Server. And then we have the Visual Studio test system, of course. These are for generating enough load to actually throw against your test environment. We have the analysis, migrate, and report toolset, the MR toolset. This is for monitoring the corresponding metrics and providing recommendations to give you an idea of which tables and store procedures to convert. And then we have the performance monitor which comes with Windows, that gives you a view of the performance counters, relevant performance counters that you might be interested in throughout the profiling process. Now, the reason that I say that scale matters is because we've done this experiment. By the way, we have a sample on Codeplex with that converts the AdventureWorks 2012 sample database to a database with in-memory OLTP elements, and that's what we used in this simple test. So we did 10 runs of this workload with varying number of threads and here, and what we found is that with one thread and with 10 threads, the performance difference, there is a performance difference, but it's not that significant, and it didn't change that much between 1 and 10 threads. But between 10 and 20 threads, the time to complete for in-memory OLTP didn't increase much, but for regular disk-based table, it almost doubled. And there's a dramatic improvement, as you can see in this graph, improvement in this graph between in-memory OLTP and the disk-based table. You can see that the regular SQL table just follows an almost exponential curve, while in-memory OLTP doesn't grow much at all. So scale in this case matters. If you test with one thread, you're not going to see as much a performance improvement as if you test with 50 threads or 100. So testing at scale is definitely something we recommend. We actually strongly recommend you to do with when you try to establish a performance baseline.
Hey, George, before you
Yes?
move on, a couple contextual questions here.
Yep.
So you mentioned that OLTP application is recommended for OLTP. If that is true, why is heavy parallel queries not recommended? And he's saying because, according to his knowledge, OLTP does have parallel queries being extensively executed.
Okay, so the parallel queries really applies to natively compiled store procedures, because currently natively compiled store procedures for each call we only execute on one thread. So there is no parallelism within an execution of natively compiled store procedure. So with that call, just only one thread executes on only one thread is responsible for the execution. So there is no parallelization within the query there. So it's with performance, a lot of things depends on your exact environment. So you might want to look at your parallelized queries, and you might want to look at the characteristics of your native compiled store procedure before you decide whether or not it's actually worth it to actually convert. It really depends.
Okay. And the last one was just if you could maybe talk about the why it's not good with full text search.
Okay. So first of all, in memory OLTP, on the memory optimized tables we have, we do not support logs, large objects. For example, varchar maxes and varchar maxes too. We don't support full text indexes. So there's going to be a lot of limitation on what you can do with textual data in a memory optimized table. So that's our recommendation is if you use heavily full text indexes, if you use heavily XML processing, you might you probably should not consider in-memory OLTP.
Okay, great. Thank you, George.
All right, so let's move on. So after you establish your performance baseline, you want to identify the bottlenecks you have within your workload that's causing it to run slow, and these bottlenecks can be resolved, and make sure that these bottlenecks can be resolved with in-memory OLTP. So what we have identified is three major areas of improvement. First area is the table contention. So in terms of contention, what we really mean here is mainly latch contention. So latches are in-memory data structures that protects pages as as writes to the pages happen. So if you have a table that's being written heavily, there's going to be there's going to be a fair amount of latch contention. To discover whether or not you have that problem, you want to look at index operational stats. This is one wonderful DMF that we have that gives you a lot of insights into contention statistics. You want to target the tables with the heaviest latching for migration to in-memory OLTP, because on the memory optimized table, we no longer have this concept of pages. There is going to be no latch contention on any of the memory optimized tables. So the logical approach would be to target tables with the heaviest latching, because all of that weight is going to disappear. The second facet, the second angle that we want to look at is the hottest table that you access. So again, look at DMDB index operational stats. This will give you the number of singleton lookups and range scans, and you want to target the table with the heaviest access. You want to target your hottest table, essentially. Sometimes, these two, the contention and the access, they will provide the same recommendations, and because you will have your hottest table is also the most heavily written to table, then it's two birds with one stone. You can migrate the table and solve both problems. And sometimes these two will recommend different lists of tables. Now, what you need to do here is to make a judgment call and determine which one is most important to you: eliminating contention or speeding up access without eliminating contention. Most of the time, I think I've seen most of the time is choosing the contention area, but it depends on, again, with anything with performance, it depends on your workload. On the store procedure front, what you want to look at is DMExec query stats. This is a DMV that provides information on all the store procedure that has plans cached within the plan cache. Now, you want to target the store procedure with the highest CPU usage, because native compilation really reduces CPU usage by a lot. So if you want to migrate some store procedure to native compilation, you want to target the one with the heaviest CPU usage. You can also, so we have tooling in place to help you make these decisions. So the AMR toolset actually does look at all of these areas and use the same data that you see, and with the algorithm that we have, provide some recommendations to your workload. Now, and then you can look at the AMR tool, and you can look at the recommendation the AMR tool generates, and that will give you some idea of how this works, of how you can pick the right objects to migrate. So the MR toolset is actually featured in the past 2013 keynote. So, but let's take a look at how the toolset actually operates. So here, give me a second. Yeah, here I have a SQL 2014 instance and SQL 2014 SSMS. The toolset has been designed to work on lower version SQL instances as well, as long as you have a SQL 14 SSMS. So you can connect to, say, a SQL 2008 instance with this SSMS, and the toolset will still work. So what we'll do is we'll set up this. The toolset actually leverages the and data collector architecture that we have. MDW, so let's make a MDW database. And yeah, let's make a MDW database, and this will finish in a minute. And this means that it also requires SQL agent to run. But the MDW database does not have to reside on the targeted instance. For example, you can make an MDW database in one of your local boxes and put your data collector on the your remote testing or production instances, and that will still work. So let's go to data collection. Yeah, this is being a little slow. Let's select the server and pick demo MDW. And here, make sure we pick a transaction performance collection set. This is the collection sets that actually collects the data that we want. Right here. And click next. We know all of that. We'll finish. So it'll start the performance collection set right away, and it will enable data collection. So what we recommend, and here you see that the data collection is actually being run here. What we recommend really is you run this for at least a couple of hours. Ideally, you want the profiling period to actually include your peak workload. You want the profiling period to include at least a cycle of your workload if your workload is, cyclic in nature, or a predicted spike if the workload is not so predictable. Now, if the workload is not as predictable as cyclic, there's a cyclic pattern. So all of this data is going to be deposited into an MDW of your choosing. So I've done a profiling run on the machine. You can detach this, by the way. You can detach this MDW and put it on another machine without losing all this data. So what we do is we go to Reports, Management Data Warehouse, and go to Transaction Performance Analysis Overview. It's a mouthful, but this is the portal report for the MR tool. So now we see we have three reports here matching the three angles of attack that we have on the three angles we have on the performance. So we want to go to contention, and here you see you want to migrate the tables in top right quadrant. So for example, the purchases quadrant, the purchases table. You want to avoid tables in the bottom left quadrant. But for tables in the top left or bottom right quadrant, you want to evaluate how much work you have to do versus how much benefit you're going to get. In these two quadrants, you have to have a little more thought to, how or whether or not you're going to take these tables to in-memory OLTP. And you can see details for the table. So we have here, we have the number of lookups, we have the number of range scans, and the predicted gain. These numbers are very, very conservative. So your predicted gain could fall within the range, or it could be higher than this. It could be higher than this. So don't be discouraged if you see, a very low number here. So because we do not know what your workload exactly is, and we cannot predict accurately how much gain you're going to get. Now it also has the latch and lock statistics. These two counters are fairly accurate. So if you have a high count over here, it may be a good. So the table is going to be a good candidate for migration. we're going to produce a similar report in the usage analysis. And for the store procedure analysis, we have the list of store procedures, and we have the amount of CPU consumed for each store procedure. So you might want to you want to migrate the highest the store procedure with the highest number of time, the highest CPU time to native compilation, and help in this case it also provides you with all the tables that the store procedure references, so that you can see which tables you need to convert to in-memory OLTP in order to migrate the store procedure to native compilation. So this is the migration tool. So we have a lot of we have quite a bit of we have quite a few considerations when we want to move some tables and store procedures to in-memory OLTP. Oops. First is whether or not the table is going to be durable. Now, in regular SQL for regular SQL tables, you really don't have a choice. If you have a regular SQL table, you know that it's durable, you know that it's locked. For memory optimized tables, you have a choice. You can either have a durable table where the operations on data are always fully logged and data is going to be recovered on a server crash, or you can have a non-durable table. A non-durable table does not involve the I/O subsystem at all. All of the reads and writes are done directly against memory, and there's no logging, no checkpointing, and there's no writes or reads from disk. Now, the downside to that is when your server crashes, all of the data inside a non-durable table are going to be lost. The non-durable table, the schema is still going to be there, and objects referencing the schema are still going to find it, but all of the data in there is going to be gone. There is no data recovery at all. So this is, you can use this when you want to squeeze out every bit of performance improvement out of the memory OLTP, and you don't really care about the durability of the data inside your table. And if you want to, and we usually durable tables are actually good for most of the needs. But for the relational cache scenario, we have actually seen non-durable tables being used to very, very good effect. Now, if you're using a durable table, there is consideration for storage. So durable tables write two kind of things to disk, and when they recover, they read two kind of things from disk. One is the checkpoint files. Each database can have a maximum of 8,000 checkpoint files. So what these checkpoint files do is these contain some of the records for recovery purposes. So when we query, when we read and write to the table, they actually are read and read from memory, but when we recover, the recovery uses the checkpoint files. So what we recommend is that you have 2 to 3 times the amount of memory consumed on disk free for these checkpoint files. For example, if you have 6 gigabytes of data inside your table, inside your memory optimized table, you might want to have around 15 to 20 gigabytes of free disk space for checkpoint files. And we recommend you use a I/O system with high sequential I/O, for example, a RAID array of spindles. And we also recommend that you spread out your checkpoint files over odd numbers of containers. Containers meaning drives, and meaning storage devices. So what this means is because checkpoint files are created in pairs, so we have a data file that contains the row information, and the delta file that contains the modified information. So these two are created in round-robin fashion. So if you have two containers, you're going to end up with one container full of data files, and you're going to end up with another container full of delta files. Yeah. So if you have these two containers, the data file container is going to get hit much more often than the delta file, and you're not using your throughput to your I/O system to its maximum potential. Now, the other consideration you have is the log drive. Index operations and the undo records are not log, so logs are much lighter than the regular SQL table. But what you want to do is you want to ensure that the log writes do not stop, do not delay the transactions too much. So you want to have a log. You want to have the log file on the drives with low latency, for example, with an SSD array or a Fusion I/O card. Now, speaking of indexes, there are two types of indexes in in-memory OLTP in contrast with the single B tree type of index in SQL. We have what we call the non-clustered index. This works similar to a B tree index, and it supports all kinds of operations. It supports range it supports range scan, it supports singleton scan. It's versatile, and it's a jack of all trades, but master of one, actually, master of the range scans and order scans operations. It performs a lot better with inequality predicate. For example, if you want to search between two dates, or if you want to search between two numbers, non-clustered index is the way to go. It doesn't need a lot of pre-configuration, but it is unidirectional. So if you want to query on an index column that's specified as ascending but sort as descending, it'll result in a table scan. Now, the more specialized type of index is the hash index. So this is essentially a hash table inside memory. And what it does is it hashes each row according to its index column values into one of its hash buckets. So it performs amazingly well with point lookups if you provide all the values for all the index columns. But what it needs, for the other operation, for example, if you want to search between 2 days, what has to happen is you have to scan through all the hash buckets, and this may slow down your performance. And what it also needs is it has a fixed bucket count configuration, and this has to be configured as you create the table. You cannot change it afterwards without dropping the table. Now, this is good for unique values. For example, if you have a primary key over a known maximum number of rows. For example, you know that you're not ever going to exceed 10 million or 100 million rows within the table, or you have some mechanism of ferrying old rows out to, say, other storage for the table. So hash index requires quite a bit of maintenance, but it performs amazingly well if you use it correctly. Now, speaking of bucket count, how do you choose it? This is a question that we hear very frequently from our internal and external users. So what we recommend is you want to choose at least as many buckets as the key space. So key space being the number of unique values in the index rows. So usually this is going to be the row count. So if you have too many keys and not enough buckets, what happens is the hash table will have a lot of chains. So the chaining will impact your point lookup. It will impact your point lookup performance, because once you find a bucket, the engine has to retrieve the values within chain and traverse through the chain. So this is going to slow you down. If you have too high a bucket count, when you do a full table scan with range scan with range queries, you're going to have to scan through too many buckets, and this is not good. This is not good. If you have a lot of recurring values, for example, if you use the number of states in the U.S. on a table with 10 million columns, with 10 million rows, you're going to have a lot of chains because a lot of these rows are going to hash the same bucket, and that's not good. Now, the other consideration is to choose the index key columns. So this applies to both indexes. It's much more important for the hash index than for a non-cluster index. One thing that's different from regular SQL tables, from regular disk-based tables, is that you can create both types of columns on the same set of key columns. For example, if you want to create an index on C1, C2, C3, you can create both a non-cluster index on C1, C2, C3, and the hash index on the same set of columns. So the query optimizer will use different types of columns, the appropriate type of index, depending on the query you issue. So you want to look at the queries carefully that uses the index. And again, you can look at the index operational stats to get a rough idea of how many range scans and how many singleton lookups that happened that happens on the index. You want to, with a hash index, you want to only choose the columns that are used in the equality predicate, because a hash index only works the best when you specify equality predicates for all of its index columns. For example, if you index C1, C2, and C3 in the hash index, the best predicate for this hash index would be C1 equals to A, and C2 equals to B, and C3 equal to C. Now, if you miss one of these, or if you use an or operator between one of these equality predicates, you're going to get table scans. And this is something that's different between the hash index and the regular disk-based index, and between the non-cluster index. Now, for the non-cluster index, what you want to do is you must choose the index direction carefully, so that most of the queries will use the same index direction that you specify. Now, once you choose the index structure, to choose the index option, you want to think about how much memory this is going to take. For each row in a memory optimized table takes a maximum of 8 kilobytes, 8192 bytes, and only 8,000 bytes are used for row content. The other thing is, because we use this multi-version concurrency control mechanism, row versions may stay in memory until they are garbage collected. So if you delete a row, it may stick around for a while before garbage collection takes place and releases the memory used by the row. So garbage collection is asynchronous, is cooperative, and is asynchronous. So it will take some time to remove the row. So you want to provision more memory than is actually absolutely minimum to actually allow for this to happen. Now, indexes contain pointers. There are no clustered indexes in a memory optimized table. So the indexes only contain pointers. The size of a hash index is fixed. It's easy to calculate. It's just how many buckets you specify times 8 bytes. The non-clustered index, the memory consumption on that is dynamic. It's a function of the row count, and it has some overhead like a B tree. So what you can do to make sure that memory consumption doesn't go out of hand is you can use resource governor to actually control how much memory is used by each database. So you can bind a database to a resource pool and then dynamically control how much memory is allocated to the resource pool to control how much memory is used by the database. And I think we have a session later on how to relieve memory pressure, and that's going to be useful once you do hit that ceiling.
Hey George, we've only got about 5 or 6 minutes left. Just wanted to.
Okay, all right. So there's the algorithm to estimate memory consumption. So this is available on Books Online. So don't worry about it. You'll have a detail. A lot of this information, a lot of this algorithm is available on Books Online. So now it comes to interpreted versus native store procedures. So a lot of the times interpreted mode, regular SQL mode, is sufficient for your needs when CPU is not a bottleneck, when you don't have stringent performance requirements. When you do have those things, native compilation can be a lifesaver. So the caveat being that we only support a very limited amount of surface area in SQL 2014 on native compilation. So you cannot migrate every single store procedure to native and make sure that and expect to do little work, because it's very involved to actually migrate a store procedure to native compilation. So you use native compilation when CPU is a bottleneck, when you have latency requirements that's not being met, and when you think that doing all this work is worth the effort. So all of these unsupported, all these limitations for memory optimized tables and native compiled store procedure, all of these are available in Books Online. So some significant ones includes check and for check and unique constraints, foreign keys, some collation constraints on index columns, nullable index keys. We don't support nullable index keys, and for example, union operator within native compilation or operator within native compilation cursors are definitely not supported, and so on and so forth. All of this is available in Books Online, and we do have some example workarounds defined in Books Online. So you can go there, or you can go to our newly defined SQL Server In-Memory Technology forum. We monitor that forum, and we'll answer your questions. We'll answer your questions on there as well, should you encounter any. So after all this is done, what we want to do is measure against the goals that we set in step 2, all the way back at the beginning of this presentation. So we want to use the same tools that we used to profile the application. So we want to use OStress again to run the same workload with the same parameters, just with different table and schema definitions. We want to compare apples to apples, that being the point. You might notice a CPU usage, a CPU increase. So you might be using 40-50% CPU, and now you might be noticing that you're using 80 to 90% CPU. This is not necessarily a bad thing, because you eliminated contention, you use CPU more efficiently, so now the same percentage of CPU is actually doing a lot more work. So now you're using all your hardware acquisitions to its maximum potential, and that's a good thing. Now, what we want to emphasize is really that this migration process is iterative. You want to go back and forth with this process, and then you want to repeat as often and as many times as necessary to get the desired performance benefits. So with recap, this is the 6-step migration process: analyze, define goals, identify bottlenecks, understand the caveats, stage the migration, and then measure against the goals. So yeah, that's the session. Any questions so far?
Yeah, thanks, George. We do have a couple. We'll try and answer these quickly because we are to run out of time here.
Yes.
Can a store procedure that is prone to recompilation still benefit from in-memory OLTP?
Well, that depends on your workload, really. If because native compilation is really compile once and run many times, and native compilation is it provides a lot of benefit over um, over your interpreted store procedure. So you'll have to test in earnest to actually find if that is worth it.
Okay. A couple questions on the AMR tool. Does it create schema objects in the target environment, and if so, will it remove them?
Okay, so with the AMR tool, it creates what in the target environment. What it creates is a set of data collectors that actually runs as SQL agent jobs. It doesn't create any tables. It doesn't create any databases. It just has a couple of SQL agent jobs running on target environment, and it ships data back to the management data warehouse, which can be on a different server. So we have another interface that cleans up all the jobs on the target environment. You can execute that and remove everything from the target environment. But the MDW is going to stay as is the data.
Is AMR available in Standard Edition, and what about in 2012? Can you use it in 2012?
AMR needs a I believe AMR needs a SSMS, SQL 14 SSMS. All you need to do is download an evaluation, SQL 14 evaluation version, and that will have AMR. And it can be, the targeted instance can be on SQL 2012. All you need is a SQL 14 SSMS.
Is the combination of full text index with in-memory OLTP not okay in the following setup? You know what, that one's probably a little too, we're going to have to send that one to the speaker because that one's a little, he gets very specific on defining out a table.
Yeah,
so.
I mean, if you have specific scenarios, we'd love to see it on our in-memory OLTP forums, in-memory technology forums, and we can examine those in detail, and we can give you a much better answer than we can, in 5 minutes.
Let's see. Can in-memory objects make use of the buffer pool extension areas or only physical memory?
Buffer pool extension. So we recommend that you put everything, in-memory OLTP, everything in memory. Now, if you want to use buffer pool extension, I'm not recommend you use buffer pool. You use buffer pool extension for in-memory data. Like this is just going to. I'm not even sure if it's going to work.
Okay.
So one thing I want to add is really what we look for really is a targeted migration scenario, which means that not all of your data is going to be in memory. For example, it's only the workload that we've seen, like the real world applications, only have 6-7 gigs of data in memory, and that's pretty much enough for a lot of really tier 1 applications.
Great, great. Well, George, that's all the questions that I have for today. Thank you very much for taking the time to talk to us today. For everyone listening, this was recorded. The slides are already posted on the 24hoursofpast.com, and they will be out. The entire presentation will be available and recorded within 1 week. You don't actually have to follow up on that. You'll get an email from GoToWebinar that will have the link to the recording in it within 1 week, so you'll get that automatically. So thank you, everyone. Appreciate you joining, and we'll see you in the next session.